morning. It is Wednesday, the last day of the week for us. For work, tomorrow we are going to be having a virtual field trip. I know you guys are all excited about that. Yesterday we finished up reviewing, adding, and subtracting fractions. I do feel like that was a much needed review just from some of the feedback that I got from you guys. So I was very glad that we had the opportunity to do that. Today, we're going to be working on multiplying by powers of 10. And when I say that, when I say powers of 10, I mean when we're multiplying by numbers like 10, 100, 1,000, 10,000, 100,000, a million, and so forth. So there are some things that we can do when we're multiplying by powers of 10 that are going to make it a lot easier for us. So this is just little tricks that we're going to work on today. So on my board, I have 3 problems. I have 5 times 10, 5 times 100, and 5 times, oh, that says 100 again. It's supposed to be 1,000, 5 times 1,000. We'll look at that in a second. 5 times 1,000. So we're going to have some visuals for you just to reinforce what it means when we're multiplying. So I have a jar here and a little bag of beans. Now I'm going to take out 5, so that's the first number that I'm working with right here. I'm going to take out 5 beans and I'm going to put them in my jar. So 1, 2, 3, 4, 5. 5 beans in my jar. Now the problem says 5 times 10. So I want to know, what does that mean? I have 5, but I need 10 times as many that are in here. So I can find that in a variety of ways. I can find out how many that's going to be. I can count them. So we're going to do that first. I'm going to go by 5s. So we have 5, 10, 15, 20, 25. Are y'all keeping up with how many that was? 30, 35, 40, 45, 50. So I put in 10 sets of 5. I put in 10 sets of 5 beans, and that gave me 50 beans. So that is one way that I can solve that problem, is just counting out how many. However, that is not something that we want to do because it's going to take forever. It will literally take a very long time to complete that. Another way that you might work a problem like this out is by saying, oh, well, I'm just going to do the multiplication. So you would take 10, you would multiply that by 5, and you would say 5 times 0 is 0, and 5 times 1 is 5. And you would get 50. Is that the same thing that I got when I counted? Yes, it is. But I think we can do it even faster. So I'm going to erase this. And we already know that it's 50. So is there anything that you notice about this? Yes. Yes, so when I'm multiplying it by a power of 10, we have 1 0 here. Look how many we have in my product. Yeah, we have 1. We have 1. We have 1. So basically what we're doing is we're going to move the decimal over to the right. So right here, there's an imaginary decimal. So we're going to move it over 1 place because we have 1 0. And that's going to give us 50. Let's see if that works with this. 5 times 100. Now, many of you can tell me what 5 times 100 is because you just know it. And if you do, that's great. You should know it. But if not, we can figure it out in multiples of ways. 1, I could count it out. I could get my jar back out and my beans, and we could count to see what 5 100 times is going to be. So I could get 100 sets of 5, and we could count that out, but that would take forever. We don't have that much time. I know you're in quarantine, but nobody wants to spend their time doing that. So we have 100, and you could just multiply it out like you do any other multiplication, times 5. So we would say 5 times 0 is 5. 5 times 0 is 5. Or 5 times 1 is 5. And we would get 500. Or, because that still takes a little bit of time, and I know you guys have things to do. You got things you need to do. We don't have time for that. So, what can I do here? I can apply the same concept that I applied here. So we have 2 zeros. How many are my product? 2 zeros. So if there are 2 zeros, I basically move that imaginary decimal over 2 times. Now the reason why I am telling you to move that imaginary decimal over is because it is going to be essential whenever I'm giving you a decimal, and you're going to see that in just a second. What direction are we moving that over? Yeah, to the right. So when we multiply, we're moving to the right. Why would we be doing that? Oh, yes, absolutely. We're making our number larger. So moving the decimal to the right is going to make our number larger. We're multiplying. It makes sense that our number is larger. 5 times 1,000. So let's look at this principle. We're not going to work it all out. We're going to see if we can figure it out. 3 zeros. We want to move our decimal place over 3 times. 1, 2, 3. So 5 times 1,000 is going to equal 5,000. Right? I told you guys this was going to be easy today. I told you. Now let's see, what if we had something like a decimal place? I told you we were going to look at that. What if I have 0.3? We're going to do the same thing. So 0.3 times 10, 0.3 times 100, and 0.3 times 1,000. Okay, so remember our rule of thumb, however many zeros we have, that's how many times we want to move over a decimal. So in this case, we have 1 0, right? So we're saying 0.3 times 10. So I'm going to move my decimal over 1 place to the right. This is why I had you think about it as the imaginary decimal. So 1 place to the right is just going to be 3, right? Because the decimal is going to be behind the 3 now. Now we have 0.3 times 100. 2 zeros. How many times are we moving that decimal over to the right? Twice, absolutely. So we have 0.3 and we're going to come over 1, 2. So my answer is going to be 30, right? Because my decimal was here. We're going 1, 2 times. All right? Last one. Some of you know what this is without even having to move a decimal. You can just look at it and know, and that's great. We have 3 zeros. That's how many times I'm going to move my decimal over. So notice whenever I have a whole number, however many, like when I multiplied by 10, that's how many zeros I added. When I multiplied by 100, I added 2 zeros. When I multiplied by 1,000, I would add 3 zeros. Well, when I'm multiplying by a decimal, it's a little bit different because we're actually going over a place value. So even though we multiplied by 10, we get 3. Okay? If you have any questions about this, please let me know. We are going to be practicing this today. This is all I want you to do is work on multiplying by powers of 10. Please don't try to multiply it out. Please try to move those decimals over to the right and see what you get. So you're working on page, 289. You're doing problems 1, 2, and 3. If you have any questions about that, or you need me to work out any of them for you, you can always let me know. I'm hoping that this is a super easy math day for you. I know some of you have been working really hard, so I'm hoping that we end our week on a good note. But if you have any questions, let me know. See you guys later.